Hello, this is me once again. The third video about Olympus Epoch 6LT. This time I'll take the straight probe. I need to figure out how to, later. And what I'll do, not perfect at all. Straight probe calibration, probe number, angle, frequency, double or single, dual. Calibration, probe delay, calibration velocity, AutoCAL here, horizontal linearity, resolution check, sensitivity calibration, amplitude control linearity. I'll check if I can do that. Save and maybe a duck curve of some kind. Yeah, just for working. So that's the plan for the straight probe. What we need is the machine. Here you go, it's already charged. I will use the number 1 calibration block, but then that's too thin, so we'll put on this, maybe do the transfer correction, check if that one and that one is the same. Okay, and then what else? That's it. Now what I do is, if it's dual, you just take this probe and the connector, there is a thing on here, and you just stick in there. Then you take another, and in here it's color coded, so wait a minute. These are colored, so you just take this, the black is to the blue, the red one goes to the red one. We need to stand this like this. Maybe you do it like this. It doesn't matter, maybe, really. Still, if we see the menu, that's okay. And then you just take the probe and put it on. That's the start. Now I'll just copy the old settings to the new place, and then go through the list where to check and what, and fill in here on the paper also. What I will do now is just put some oil on the block and put this probe here, and I don't think I will have to move it much. That's it. Now I'll go copy the settings. Yeah, not that nice. Okay. Home. Now into manage. Brain is already frozen. I need to rest maybe on Sundays. That's what I have. Enter, copy, and I will make it X, so it's at the bottom. 0. I'll just pause. That's what I have written. 0 degree with an X, so it goes down 4 megahertz number and my initials. Copy. Now I need to put this X0, here it is. I need to put it, open it, because it's not this. Escape. Okay, so I will move the stat here. It shows 26, 466 and it's on 25, so let's check if it's good or not from the start. How many can we get? Yeah, we have the dark curve. We just copied off the 5. Escape. Let's move. That should be 50. That's close enough. That should be 75. That should be 100. That should be 125. That should be 150. Okay. I just copied, but what we need to do is I have made the name now to put the 0 in the angle. I'll need to delete the duck so we can calibrate. 0 in the angle. That's 0. Thickness is 0. Well, let's make it 25 because that's the thickness. Maybe it will change something, I don't know. X value, there is no such a thing. Where is dual? Now, frequency is in pulsar and receiver. Here is dual. I go delete the duck. Not delete. Off. Maybe now we can change some things. Pulsar. That's dual. That's frequency 4. Escape. Now receiver. This is listening. So 4 is in the middle. Okay. Now what else? Double or dual was in pulsar. Okay. Just pause and write. Here. The dual is in pulsar. Now the calibration part. I'll put it here because I don't I don't move the probe, so no problem with that. It should stand where it is. I'll go save. Save on this new one. Okay, now P is on. I want to turn it off. Okay. Now let's go to the calibration, to the big menu. Here. I will take 25 and maybe 1, 2, 3, 4, 5, 6, 7. Okay, so 5, that's 100, 150. So that will be 100. it would be nice if this thing would be programmable, because I'm turning it. I need to think what I am doing. Come on. Because I'm turning it 95% of the time into a different direction. That should be 25, the first one, and then many reflections. Start is here. Here. Do other. It's off somehow. This wheel is off, and if it's programmable, I need to find out where the direction is. Okay, collect the first one. It should be 25. I'd like to have it 25 and exactly 150 plus minus 0.5. That will be perfect. Let's see. Enter. Second one, this one, 120, 150. Yeah. Somehow it's not where it should be. It goes. Okay, here it goes. Success. I go save it. Enter. Okay. I'll write down the velocity and probe delay. So where is it? It's in probe delay. I didn't write it down. I need these videos so I don't have to think. Come on. It will be in... No. It's in UT. So what I have written is AutoCAL. When you do it, you can find these two things in UT of the menu, and this is the velocity of the AutoCalibration, and that's the probe delay of this. Okay, now let's check horizontal linearity. Do these show what they should show? Okay, let's go there. So yeah, that's the end. Good enough. Now up. Yeah, I already know a bit where. Okay, 175, good. 150, 125. Why is it changing? Okay, now it doesn't change. 0.7 already off. Very bad, very bad. Okay, 200. It somehow changes here. I need to push it. It's a little bit off. Okay, 75, 50. Okay, 3 of the 100th of the millimeter. So that's the what? The horizontal. No, not this one. Linearity, resolution check. I will save and we'll do the resolution check on the block on these. You cannot see. There it should be. We should see 3 spikes there. Let's move. I'll pause. That will be already not perfect because that's 25 and that's bigger. So what I need to do is put it maybe like this, so both of the parts get to touch this. Yeah, it's not very a lot of, it's a little bit, and I will leave it here. Now let's increase decibels. That I think should be 85, 91 and 100. So we have a small gate, so I will go on them, and as I remember it should be from the beginning 85 plus 91 plus 100, like this. Okay, you can see that. It's great. Let's move the gate. No. $85 is, yeah, plus minus plus 0 to 15, then this thing is 91. Yeah, that's better. And that one 100. Okay, 17 off. Yeah, so that's the resolution check in here. Next, sensitivity calibration of the small hole. I will decrease the range because we are working not with like 170 but with 40 millimeters, and I'm not sure how to check this one with oil, so let's do this way. Now I'll just leave it here. I need this thing. That one is there. Good enough. No, that's okay. Move the gate. The hole is 15 millimeters in the depth, so okay. Good enough. I found it. We can increase the decibels if we want, but okay, here it is. 15. Now I'll try to move it here. It should be 35, but 35 will be somewhere let's make it 32, and we can catch it maybe here. Let's do it this way. Up, and now up. Okay. Here it is, 34. It appears and disappears, appears and disappears. Okay. This one appears and disappears. Good enough. What else? Amplitude control linearity. Okay, let's try this. I have put the probe on this 25 and now I will decrease. I will increase the range. Okay, now I need to increase this to 80%. Come on, not this. 80, that's 80, 60. No, that's off. And these are messed up. But that's the percent. Maybe this one shows what I need. %81. Okay, that's useful then. Yeah, maybe we should put this percent here because it says what percent of the screen it is. That's a useful number. Okay. I already don't know what I'm doing. Okay, now I need to decrease this by 6 decibels and it should become 41. Enter. Up. Now it's, yeah, I will just change it so it's 0. Okay, enter. Add. Okay, now it's 0, so I will make it -6 here. And it's 81. No. Okay, that's 41. Yeah, so -6 is 41, exactly as it should be according to the book. Here it's 81. So 6 decibels makes it half of the screen. That's amplitude control linearity. We should save it. Or I should save it. If you are doing this, save it. My son is calling. I need to pause video. Okay, video stopped, so I will stitch it together. Now, let's make a duck out of these things. So what I will do is, okay, let's do like 6 spikes. So, okay, save, enter. Let's save what was there. I don't remember what I done there. It's still green, so it's full while I am working, so it's a good thing. You can work with it connected. So range, increasing the range. Okay, so 80, that's 20. So if I want to work with duck, that's the last point I need to make. Oh, then it will be down there. Still, maybe, yeah, it's 80-20. So if you, according to the standards, you should work, or if I increase there, then yeah, we can put it over. Okay, so yeah, let's do it this way. So okay, range is good enough. Escape, maybe peak memory, let's put it on. Escape now decibels. Let's increase it a little bit to 90. Yeah, let's increase to 95, let's say. So it will be an equal number here. Let's add this then. Enter, add 80, 48 will be our baseline of the duck. Let's do this way. So maybe there we can get the lines. Okay, so duck dB will be 48. That's too high for this graph, but yeah. There it's good enough. There you cannot see anything. So now, okay. And I need to check the, yeah, it's good enough, the connection. So I am not moving it. Okay, now let's save. All right, now let's go to dark. That's in sizing, dark setup. I want it dark, not TCG. Yeah. Let's make it custom. On. Let's put it off because it. Let's try it. I don't have time and brain already is frozen. Curve. Let it be curve. And then what I want is -6, because -6 decibels will be where the indication starts. Maybe we should read the standard, but one of the ways to measure where the ends and begins is -6, so it's half. I maybe will explain it with paper later, but let's do this. 1, enter, -6, enter. I want this. Now escape. Now add. So I will make, that's, yeah, let's put it to here, but we don't have this thickness to work with, like 150, so it's like 15 centimeters in depth. Okay, yeah, add, this point is good point, add, enter, first one, then go not this direction, that should be 50, enter, add, go not this direction. I turned it 95% of the time in the wrong direction. Maybe it's just me. Come on, this way. No! I cannot curse on YouTube. I'm okay. Yeah, add. Now this way. Yeah, good. Good then. Now, okay. 150 exactly. Calibration is perfect. Yeah, on this. I did this on this and on this. Others might be maybe off, but that's okay. Add. I can do more. It's doesn't matter. And then add this one. Okay. Then done. No. Escape. So what I have here is the dark curve of many points, and where can I demonstrate it? I cannot. I will pause. The idea is like this. When you have a probe, it goes something like this. The idea is, but if it's double, it's not like this. It goes somehow like this with an angle and then reflects, and it reflects inside. So that's more of the idea, but it goes like this, okay? And then the decibels is of this thing here. Okay, now if you move the probe like here, half of it, yeah, then what it does is it shines the sound here, yeah, and half of it reflects of this thing, and half of it is this thing, so it should show something like this. Yeah, no, the idea is different. Yeah, if you put it here, yeah, if you put it here, the spike in the screen will be like, if this is the 40 millimeters, yeah, so the spike will be like this. Now if you put it like here, it will shine, but it will go through this and there will be nothing. So this spike will be like this, small, because half of it returns and half of it disappears. Okay, so that will be half, or minus 6 dB. Okay, now if you move it like here, all of it disappears, and in the screen there will be nothing, because if the range here is like 8 and there is like 20, so no spike, you have no return signal. Okay, now if you move like here, it will all reflect half. Okay, so the spike will be like half, and if you move it like here, the spike, the sound will reflect all of it, and then the spike will be high. So the idea is of this minus 6 is half, and if it's half of here, that's where the defect or whatever is there is the start. So if it's if in here, yeah, so this is the idea. The idea is that when the spike reaches here, it's half, so it's the edge, it's directly under the half of the probe, yeah, then it disappears, and then when it reaches this line, I don't have the means to demonstrate it. Okay, so then you have come from this part to this part, yeah, and here you can measure, mark on the metal whatever you have to mark. Okay, so that's the line, the idea of this line, half of the spike, minus 6 decibels. Okay, there are other methods, but that's the idea of this thing, of this line. Yeah, let's pause. Now what I will do is put it on the DAC block, and we have one hole in 5, 25, 20, so that's the reflection, 35. Okay, so just frozen, escape. What is this? Oh, it's P on. Okay, P off. Let's put this peak memory off. Okay, now there are no lines. Okay, so let's demonstrate and check what we can find. No. We will do it here. We will do it here. We will do it where is nothing. I need, yeah. So 35. 35 is, I will make the range like 40. So we don't see, and yeah, the transfer correction, let's do that. So when I have put here, yeah, on the duck, you can see that the spikes are up over the biggest line, yeah. So if I move the decibels, whatever I want, what should I move? No, let's do it there. Transfer correction will be so, not this way. Here. If I work with the depth of 35 or something, here is thickness. I need decibels. Wow. Let's put it somewhere. Maybe this one? No, I need some kind of amplitude. Okay. Maybe this one? No, that's the same one. Let's try this one. I'll pause. Okay, here you go. Decibels only a little bit over, so 0.3 more. What I have put there is decibels to curve. I will save it now. So that's a little bit over the top line. Now if I go not this direction, here, that's also plus 303. Now this one is already 1.5 decibels over the line. That's one, all two, that one. I need to move it up or down. Okay, so depending on your working conditions and thickness, you might do transfer correction of 2 or like 1.5 or like nothing or 0.3. So the sound in this block goes a little bit better than in the V1 block. Okay, so there you can see it's over the line, it's not under the line, yeah? But if I move, I can get it like lower here, yeah? If there is a worse connection or better connection or whatever. Let's do it this way. Okay, so here. It's empty here. It's on the space that is empty. So more oil, more lubricant, more whatever here. It goes up over. Yeah, so it depends on your working conditions. But that's kind of transfer correction. Okay. Now let's decrease the range. I need only 40, so I need what's inside the block. Let's see, 35, let's do 40. Okay, that's good enough. So now there is nothing in the middle because there is empty here. What we will find here is maybe something or maybe nothing. No? Here you see nothing. Yeah? Only it's decreasing here. Okay. Here is something. This one. That's near. Okay. This one is very near to the surface. So it should be somewhere here, but there is nothing. You can see. You cannot see this whole. Yeah, maybe you can. Wait a minute. I need to put this peak thing on so we will see what it shows. Okay. Now, here you go. Okay, here is something. We can find this thing. Yeah, okay. Now this thing, wow, that's nothing. But when I am over it, you can see what's the height. It scatters the sound around, so it decreased, but or maybe all is not there. Okay, so this thing, okay, here we found this defect down there. Okay, now this one, nothing. And what is there? I have no idea. Okay, let's measure this one. That one is 25 depth. Not this direction. 23. Yeah, 23, 20, whatever. So this is the hole that we are seeing. This one we cannot see. Let's move to this one. It should be depth 20 plus 18. And I don't know. Let's check. Yeah. So this one, here is the defect, this hole. Okay, so you can find something. Yeah, but it's, and where it starts and when it ends, that's a problem. But here you can see how, and the reflection here is 35. So if you are checking something that you just check with this thing, and that's 35 there, you can put this number here and scan the number, so it's the same. Why is it? Okay, peak off, because this one, I think it's stuck there. No, it's still there. Let's check. Start. Strange. R 1%. You should put whatever you want here, so it shows you maybe here this should be, and that's okay. I'm already tired, so I won't make anything more. That's the demonstration of you just go scan and then you find something here. So here is a defect. Then you find something else. Here is a defect. Yes, that's the way you scan the surface, and of course that's the demonstration, but I need to check the paper and to finish this thing. Where is it? Here. So that's the duck, and then what is the 85, the 85. the baseline. Okay, I'll show myself now. So when you do this, you need to check the standards, you need to check your procedure, you need to check with a straight one how you are looking for the defects, because there are different ways to do this. It's not a standard one with this calibration dark block. No, there are other things that, so you should check how you do it, but that's the demonstration that you can find something. But the size, the distance, the direction, the place, how you mark it, that's a different thing. That's not for this video. So that's the menu and things of the Olympus EPOCH 6LT calibration with a straight double dual probe. That's it for today. I don't want to do any more now. Okay. Yeah, if you have any questions, leave them. Yeah, that's it. Thank you for your attention and rock us after half a year. Good luck with this Olympus thing. And happy Christmas and no, yeah, and happy New Year also, because it's already like not 10 days, 15 days to Christmas, but still. So let's celebrate the way that you want to celebrate it, with the best people around you that you can get. Okay, see you in the next video.